Hello guys, so now this is the engineering knowledge motto October 2015 past question solution. So now question 1 is with reference to slow speed diesel engine turbocharging. A. Explain why electrically driven scavenge air blowers are sometimes fitted. B. Describe how a turbocharger may be disabled to allow for operation of the main engine in the event of the failure of the turbocharger rotor. C. Describe the procedure for running an engine in the event of a turbocharger not being operational. So the answers are below. So now we're going to be making reference to the low speed diesel engine turbocharging. So now question 1, we are asked to explain why electrically driven scavenge air blowers are sometimes fitted. So the reason why electrically driven scavenge air blowers are sometimes fitted are as follows. Number 1 is to improve scavenging. So the electrically driven scavenge air blowers help to enhance the scavenging process by providing additional air to remove exhaust gases from the cylinder. So the word scavenging means is the ability to remove the word exhaust gases. So electrically driven scavenge air blowers help to improve the word scavenging. Secondly is load flexibility. Electric blowers allow independent control of the scavenge airflow, enable better load response and flexibility during engine operation. So electrical driven scavenge air blowers helps in load flexibility. Thirdly is redundancy. In the case of turbocharger failure, electric blowers can serve as a backup system. So the ability for the turbocharger and the electric blowers to serve as a backup system helps in improve the redundancy. So now the second question we're asked is describe how a turbocharger may be disabled to allow for the operation of the main engine. So they want us to describe how a turbocharger will work when it's being disconnected from the main engine. So in order to do this, to disable a turbocharger and allow operation of the main engine in the event of a turbocharger rotor failure, the following steps can be taken. Number 1, firstly you need to secure the turbocharger. Shut off the fuel supply to the turbocharger to prevent the introduction of additional fuel into the malfunctioning turbocharger. Firstly, you need to disconnect any source that brings fuel supply into the turbocharger. Secondly, disconnect the turbocharger. Disconnect the mechanical linkage between the turbocharger rotor and the engine crankshaft to isolate the failed turbocharger from the engine system. So first of all, you need to disconnect the mechanical linkage between the turbocharger rotor and the engine crankshaft. Thirdly, adjust the engine parameters. So adjust the engine parameters such as fuel injection timing and quantity to compensate for the reduced air supply from the disabled turbocharger and ensure proper combustion. So thirdly, you need to adjust the engine parameters. These engine parameters include the fuel injection timing and the quantity. So now the C part of question 1 is describe the procedure for running an engine in the event of a turbocharger not being operational. So when the turbocharger is not being operational, they were asked to describe the procedure for running an engine in that event. So now the procedure for running an engine in the event of a non-operational turbocharger is as follows. Number 1, adjust the engine parameters. Modify the engine fuel injection timing and the quantity to compensate for the reduced air supply caused by the non-operational turbocharger. So you need to adjust the engine parameters. Secondly, you need to monitor the engine conditions. Continuously monitor the engine operating parameters. Thirdly, you need to perform regular inspection. Fourthly, you need to arrange repairs. Arrange for necessary repairs or maintenance of the turbocharger as soon as possible to restore the engine optimal performance. So in order to work it, number 1, you need to adjust the engine parameters. Secondly, you need to monitor the engine condition. Thirdly, you need to perform regular inspections. And fourthly, you need to arrange repairs. Question 2. With reference to medium speed diesel engine cylinder liners, A. Explain the cause and effect of liner polishing or glazing. B. Explain the action of an anti-polishing ring during the operation of the engine. C. Describe how effective cylinder lubrication is achieved. So the first question we're asked to explain the cause and effect of liner polishing or glazing. So the answer with reference to the medium speed diesel engine cylinder liner, A. The liner polishing or glazing occurs due to insufficient lubrication or poor quality lubricating oil. The cause can be attributed to high operating temperature. So when the temperature is very high, this can what cause it. Inadequate lubricating oil film or abrasive contaminant in the oil. The effect of linear polishing or glazing include increased what friction, reduced lubrication, accelerated wear, and potential damage to the piston rings and the linear surfaces. It can lead to increased oil consumption, decreased engine efficiency, and compromised engine performance. So now with reference to medium speed engine cylinder, linear polishing and glazing, so this is due to insufficient lubrication. B. An anti-polishing ring is designed to prevent linear polishing or glazing. During engine operation, the anti-polishing ring is fitted in the top part of the cylinder liner just below the top compression ring. So in regards to the question, we are asked to explain the cause and effect of linear polishing or glazing. B. Explain the action of anti-polishing ring during the operation of the engine. So in B, we are asked to explain it. And during engine operation, the anti-polishing ring is fitted in the top part of the cylinder liner just below the top compression ring. It works by disrupting the smooth polishing action of the piston rings on the linear surface. The ring is typically made of harder material than the liner, such as cast iron, and has grooves or protrusions that break up the oil film and promote localized scraping. This scraping action prevents excessive polishing and glazing, maintaining an appropriate level of surface roughness on the liner for optimal lubrication. The C part of the question is describe how effective cylinder lubrication is achieved. So now, effective cylinder lubrication in medium speed diesel engines is achieved through the use of a dedicated lubrication system. The lubrication system typically consists of cylinder oil pump, a lubricator. So this cylinder oil pump is a pump that supplies the cylinder lubricating oil to the liners. It ensures a controlled and sufficient flow of oil. Lubricator is a device that meters and distributes the lubricating oil towards each cylinder. Atomizers, these are devices that atomize the oil into fine droplets for efficient distribution and adherence to the linear surface. Distribution system is a network of pipes and channels. And the oil scraping rings, the rings are fitted on the piston that remove excess oil from the linear surface. The lubricating oil used for the cylinder lubrication is formulated to withstand high temperature, provide adequate lubrication and protection, and minimize linear wear. The lubrication system is designed to deliver the oil precisely, ensuring sufficient lubrication between the piston rings and the linear surfaces, reducing friction, minimizing wear, and maintaining efficient engine operation. Regular monitoring and analysis of the lubricating oil condition and properties are essential for maintaining effective cylinder lubrication and preventing linear related issues. So that is regards to question 2. We're asked to explain the cause and effect of linear polishing and glazing, explain the action of anti-polishing ring during the operation of the engine, and C. Describe how effective cylinder lubrication is achieved. And we have explained it by giving the different parts. We have the cylinder oil pump, the lubricator, the atomizers, the distribution system, and the oil scraper rings. So now the third question is, with reference to engine fuel injector nozzle cooling, explain why fuel injector nozzle cooling is necessary. So they want us to explain why fuel injector nozzle cooling is necessary. And B. Describe with the aid of a sketch the operation of a nozzle cooling system for a generator engine. And C. Explain how fuel injector nozzles are cooled on engines which are not fitted with a separate nozzle cooling system. So we'll be making a reference to the engine fuel injector. Answer. So now with reference to engine fuel injector nozzle cooling, A. Fuel injector nozzle cooling is necessary to prevent overheating of the nozzle due to high temperature of the injected fuel. So when the fuel is injected into the combustion chamber, it undergoes a rapid increase in pressure and temperature. If the nozzle is not adequately cooled, the high temperature can cause fuel cocking, or carbon deposit to form on the nozzle, leading to poor fuel atomization, reduced combustion efficiency, and potential damage to the injector. So cooling the nozzle helps to maintain its performance, prolong its lifespan, and ensure proper fuel spray characteristics. So this is in regards to A, which is explain why fuel injector nozzle cooling is necessary, and this is it. So the cooling of the nozzle is necessary to help to maintain its performance, prolong its lifespan, and ensure proper fuel spray characteristics. So now the B part of the question is describe with the aid of a sketch the operation of a nozzle cooling system for a generator engine. So in regards to that, a nozzle cooling system for a generator engine coolant is circulated through passages surrounding the fuel injector nozzle. The system typically consists of the following components. So there's what is called the coolant supply, the cooling jacket, and the cooling pump. So you should know that there are parts of it. We have the basically 4 parts: the coolant supply, the cooling jacket, the coolant pump, and fourthly the coolant temperature control. So the coolant is supplied from the engine cooling system or a separate cooling circuit. It is pumped through the cooling passage to provide adequate cooling around the injector nozzle. So the next one is cooling jacket. A cooling jacket is a surrounding structure of chamber that encloses the nozzle. We have the coolant pump. A pump circulates the coolant from the supply through the cooling jacket and back to the coolant source. Then we have the coolant temperature control. The coolant temperature is regulated using a thermostat. So there's a thermostat that helps to control the temperature. So now the C part of the question is explain how fuel injector nozzles are cooled on engines which are not fitted with a separate nozzle cooling system. So we're asked to explain how a fuel injector works when it's being separated. So on engines that are not fitted with a separate nozzle cooling system, fuel injector nozzles can be cooled by the engine's internal cooling system. In this case, the coolant that circulate through the engine cooling passages also flows around the fuel injector nozzles, providing some degree of cooling. The engine cooling system, which includes the radiator, the water pump, coolant passages, and heat exchangers, helps to maintain the overall temperature of the engine component, including the injector nozzles. However, the cooling effectiveness may be limited compared to the engine with dedicated nozzle cooling system. It is important to ensure that the engine cooling system is properly maintained and functioning to provide sufficient cooling to the injector nozzle and prevent excessive heat. So this is at the step. So on engines that are not fitted with a separate nozzle cooling system, the fuel injector nozzles can be cooled by engine internal cooling. So by the use of internal cooling, this can serve the purpose. So number 4, while operating in a heavy weather, the main engine loses power and misfires. Investigation shows considerable quantities of water in the fuel. So now they're asking you, as a chief engineer officer, explain the immediate actions which should be taken to ensure safe operation of the ship. B, state with reasons the possible sources of water entering the fuel storage, handling and supply system. C, as a chief engineer officer, write the standing orders that would be issued with respect to operation of the fuel storage, handling and supply system. So the first question, as a chief engineer officer, they want you to explain the immediate actions which should be taken to ensure the safe operation of the ship. So number 1, you need to stop using the contaminated fuel. Immediately stop using the fuel that contains considerable quantities of water to prevent further damage to the engine. Next, drain and clean the fuel storage tanks. Drain the affected fuel storage tanks completely and clean them thoroughly to remove any remaining water and contaminants. Thirdly, replace fuel filters. Replace the fuel filters to remove any water and contaminant that might have entered the fuel system. Next, you need to purge the fuel supply system. You need to flush the entire fuel supply system, including the pipes, the filters, and the pumps, with clean fuel to remove any residual water and contaminant. Next, you need to check the fuel supply lines and connection. So it's possible that the issue might be from the fuel supply lines and connections. So you need to inspect all fuel supply lines, the valves and connection for any sign of leakage and damage. Repair or replace any faulty component as necessary. Next, you need to refill with clean fuel once the fuel system is clean and free from water. Refill the storage tanks with clean dry fuel from a reliable source. So the source must be reliable. Next, you need to monitor the fuel system performance. Continuous monitoring of the fuel system and engine performance will help to ensure that there are no further issues and that the engine is operating smoothly. So now the big part of the question is, they want you to state with reasons the possible sources of water entering the fuel storage, handling and the supply system. So now the possible sources of water entering the fuel storage, handling and supply system can be one, contaminated fuel supply. So water can enter the fuel system if the fuel supply to the ship is already contaminated with water due to improper storage or transportation. So the issue might be from the source in which the fuel is being bought. Next is condensation. Temperature changes can cause condensation inside the fuel storage tanks, leading to the accumulation of water in the fuel. Next is leakage or damage in the fuel storage tanks. So there might be possibility of cracks, faulty seals or damaged tank vents, and this can allow water to enter the fuel storage tanks, especially in heavy weather conditions where waves and rough seas can lead to water ingress. Next is improper maintenance. When there's inadequate maintenance of fuel storage tanks, fuel filters and fuel supply system, components can result in water contamination. So now the C part of the question is, okay, let's go back to the C part of the question is, as a chief engineer officer, write the standing orders that would be issued with respect to operation of the fuel storage, handling and supply system. So as a chief engineer officer, we want you to give some orders in regards to the issue. So now, as the chief engineer officer, the standing orders that would be issued with respect to the operation of the fuel storage, handling and supply system are as follows. Number one, regular fuel system inspection. So as a chief engineer, you're going to ensure that there will be regular fuel system inspection. That means you conduct regular inspection of the fuel storage tanks, filters and supply lines to ensure they are clean, free from water and in good working condition. Next is strict fuel quality control. You ensure that there is strict fuel quality control, so that anywhere that buying the fuel, that there is a high quality control of where the fuel is coming. So you implement a strict fuel quality control procedure, including regular fuel testing to ensure that the fuel supply meets the required specification and is free from water and contaminants. Next, you can be able to ensure proper fuel handling. Ensure proper handling of fuel during the storage, transfer and bunkering of operations to minimize the risks of water contamination. This includes using approved fuel transfer equipment and following the established procedures. So you can be able to ensure 1. Regular fuel system inspection, 2. Strict fuel quality control, 3. Proper fuel handling, and now 4thly, prompt reporting of the fuel related issues. Immediately report any signs of water contamination or fuel system malfunction to the relevant personnel. So as a chief officer and the vessel management, you can be able to give rules and orders that there should be prompt reporting of the fuel related issues. Next is crew training and awareness. You can train your crew and give them proper enlightenment. So now, provide proper training to the crew members regarding fuel handling procedures, detection of water contamination, and prompt response toward fuel system issues. Documentation and record keeping. So maintain accurate records of fuel quality tests, maintenance activities, and any incident related to water contamination in the fuel system. So by implementing these standing orders, the ship can maintain a clean and reliable fuel system, maintaining the risk of water contamination, and ensuring what a safe and efficient operation of the what main engine. So now, in regards to the fifth question, which is with reference to a diesel engine cylinder head exhaust valve, they want us to state with reasons the indication of a valve burnout. So when a valve is being burned out, what are the indications? B, they want us to state the causes of a burnt out valve. So what causes a burnt out valve? And thirdly, describe the onboard procedures and practices that would minimize what valve failure. So they want us to give some steps and what procedures and practices that will help to reduce valve failure or what burnout. So in regards to the first question, the indication of valve burnout in diesel engine cylinder head exhaust valves may what include the what following. When there is high exhaust temperature, the valve burnout can cause the exhaust gas temperature to what rise what significantly, which can what be indicated by what abnormal temperature readings on what exhaust gas temperature sensors or pyrometers. So a pyrometer is a device that what uses to what measure what temperature readings. Next, loss of what engine power. So now burnt out valves can lead to what loss of what energy power due to the what inefficient combustion and what compromised cylinder sealing. So when there's loss of energy power, this might what lead to what burnout of what valves. Next is what irregular engine operation. Valve burnout can cause engine misfire through what idling or what irregular engine operation. So when there's irregular engine operation, valve burnout can what occur. Next is what increased fuel consumption. So inefficient combustion might result to what fuel valve what burnout. Next is abnormal exhaust of emission. Burnt out valves can what cause abnormal what exhaust emission, including excessive smoke, unburned fuel, or high levels of harmful pollutants. So when there's excessive smoke, this can lead to a valve burnout. So now the B part of the question, we were asked to state the causes of a burnt out valve. So what are the causes? Number one of the causes is overheating. The cause of burnt out valves in diesel engine cylinder head exhaust valves may include overheating. Excessive operating temperature may lead to what overheating. Next is what poor valve seat contact. So when the valve seat is not properly sitting well, this may lead to is one of the causes of what burnt out valve. Thirdly, incorrect valve clearance. So incorrect valve clearance adjustment can cause the valve to not sit what properly, leading to excessive valve temperature and burnout. Next is what combustion what abnormalities, which we have already spoken. Irregular combustion events such as detonation or pre-ignition can subject the valve to higher thermal and mechanical stresses. Next is what contaminants in the fuel or lubricating oil. So impurities or abrasive particles present in the fuel or lubricating oil can cause what accelerated wear and damage to the valve surface, leading to what burnt out. So these are the what causes. So number one, overheating, poor valve seat contact, incorrect valve clearance, combustion abnormalities, contaminant in the fuel or lubricating oil. So now in regards to the C part of the question is describe the onboard procedures and practices that would minimize the what valve failure. So they want us to give steps in order to prevent what valve failure. So now to minimize valve failure and reduce the risk of burnt out valves, the following onboard procedures and practices should be what implemented. Regular maintenance and what inspection. Establish a scheduled maintenance program that includes what regular inspection of the what cylinder. So regular inspection will help to what minimize the what valve burnout. Next is proper valve clearance adjustment. Ensure that the valve clearance is adjusted with the what manufacturer specification limit to promote proper valve seating and minimize excessive valve temperature. So now proper valve clearance from the manufacturer is very essential to ensure that the valve doesn't what burn out. And thirdly, quality fuel and lubrication oil. So the use of high quality fuel and lubricating oil that is free from contaminants can help to prevent what valve burnout. And effective cooling system. So a very good cooling system can also prevent what valve burnout. So maintaining the cooling system in good condition including the cooling water supply, the heat exchangers, the cooling jacket. This will help to prevent excessive heat buildup in the cylinder head and valves. So now, correct installation and seating. So ensure that the valves and the valve seat are properly installed and ground to achieve optimal contact and sealing. Regular cleaning and decarbonization. Periodic cleaning of the valves and the removal of carbon deposits will help to prevent valve burnout. Next is monitoring and analysis. So continuous monitoring of the engine performance, the exhaust gas temperatures and emissions, and to detect any abnormality at the moment will help to prevent valve burnout. So by implementing these procedures and practices, the risk of valve failure, including valve burnout, can be minimized, leading to improved engine reliability and performance. So now the next question, which is question 6, is we are asked to write a report to the engineering superintendent regarding the failure at sea of a crosshead main engine bottom and end bearing. The report must 1. Explain how the defect was detected, 2. The immediate action taken to prevent further engine damage, 3. The subsequent action taken to ensure that the vessel was able to continue on passage to the next port, and next probably the cause of the bearing failure and other checks made on the engine. So in this case, they want you to write a report, and this is the format in which you can write the report. So now, first of all, write the subject: report on the failure of the crosshead main engine bottom end bearing. So you write the date to the engine superintendent, write the person name, then then your name as the chief engineer officer, and then you now put dear engineer superintendent, his name. So you can now start. I am writing to inform you about the recent failure of the crosshead main engine bottom end bearing that occurred during our voyage. I would like to provide you with a detailed account of the incident, the actions taken, and the subsequent measures implemented to ensure the vessel's continued safe operation. So you now start with the detection of defect. During routine engine rounds and inspection, abnormal noise and increased vibration were observed coming from the main engine. The engine monitoring system also indicated a rise in bearing temperature and fluctuation in oil pressure, both of which are indicative of a potential problem with the bottom end bearing. Next is you need to write the immediate action. To prevent further damage to the engine, the following immediate actions were taken. The main engine was immediately shut down to avoid exacerbating the issue or increasing the issue and ensuring the safety of the crew and machinery. The affected bottom and end bearing was inspected visually to assess the extent of the damage. Lubricating oil samples were collected and analyzed to determine the presence of an abnormal particles or contaminants. So, ensuring the continuity of the voyage. In order to continue our passage to the next port without delay, the following actions were undertaken. The spare bottom end bearing was retrieved from our inventory and prepared for installation. The damaged bearing was carefully removed from the engine, ensuring no further damage was caused. Thorough cleaning of the bearing housing and related components were performed to remove any debris or contamination. The spare bearing was properly installed and aligned following the manufacturer guidelines and specifications. The lubricating oil system filters were checked and replaced to minimize the risks of further contamination. A comprehensive inspection of the entire main engine system was conducted to identify an additional signs of damage or wear. So now, after giving that, next is give the probable cause. Based on our initial assessment and observation, the problem cause of the bottom end bearing failure is believed to be excessive wear resulting from prolonged operation under unfavorable lubricating oil conditions, such as high levels of contamination or inadequate lubrication. Further investigation and analysis will be carried out to confirm this initial assessment. So you can now go next and write about the additional checks. To ensure the reliability and integrity of the engine, the following additional checks were performed. So number 1, measurement of the bearing clearance were taken to assess if any other components were affected. Condition monitoring techniques such as vibration analysis and thermographic inspections were employed to identify any other potential issues within the main engine system. Lubricating oil analysis was what intensified to monitor the condition of the oil, identify any potential contaminant, and adjust the oil maintenance program accordingly. The entire lubrication system, including the oil coolers, the filters, and the pumps, was what inspected and cleaned to minimize the risk of what future bearing failures. So now you cannot end with a conclusion. In conclusion, immediate actions was taken to mitigate the damage caused by the failure of the crosshead main engine bottom end bearing. The spare bearing was promptly installed, allowing us to resume our voyage safely. The probable cause of the failure is believed to be what related to what unfavorable lubricating oil condition. We will continue to monitor the engine closely and carry out necessary inspection to prevent similar incidents in the future. So should you require any further information or clarification regarding this incident, please do not hesitate to contact me. I remain at your disposal. Sincerely, your name and your Chief Engineer Officer. So regards to the seventh question is state with reason 6 points which should be covered in a risk assessment for the replacement of a crosshead main engine fuel injection pump in what the pump. So they want you to give 6 points which should be what covered in a risk assessment for the replacement of a what crosshead main engine fuel injection pump. And B, they want you to write instruction for the replacement of a crosshead engine main engine fuel injection pump. So the answer, the 6 points to be covered in a risk assessment for the replacement of a crosshead main engine fuel injection pump in the port is 1. Safety precautions. So safety precautions must be taken with high necessity. So assess the potential hazard associated with the replacement process, such as electrical shock, fuel leakage, fire, or personal injury. Identify safety measures to mitigate these risks, including the use of what personal protective equipment (PPE), proper grounding procedures, and what firefighting equipment. So the 6 points you need to cover in the risk assessment is what safety precaution. Secondly is competency and what training. Ensure that the personnel involved in the replacement process are adequately what trained and competent to carry out these tasks, because this task is really a high demanding task. So competency and training are of high necessity. Next, you need to verify their knowledge of fuel injection system component procedures and what safety precaution. Thirdly, equipment and what tools. Evaluate the availability and suitability of the what specialized tools and equipment required for the pump what replacement. Ensure that they are in what good working condition, properly calibrated, and appropriate for the what specific engine model. So one, you need to talk about safety precautions. Secondly, competency and training. Thirdly, equipment and tools. Fourthly, one needs to look at the what fuel system what isolation. Determine the procedures for isolating the fuel system and removing the fuel pressure to prevent what unintended fuel discharge or leakage during the pump replacement. Include steps for draining the fuel from the pump and associated lines to minimize the risks of environmental contamination or what fire hazard. So you need to look at the fuel system isolation. Then fifthly, look at the environmental what protection. Consider environmental factors such as proper contaminants and disposal of fuel and lubrication to prevent what pollution. So the contaminants and the disposal of the fuel should be what properly kept to avoid what pollution. Next is what risks of system misalignment or what damage. So access to risks of improper pump installation, misalignment, or damage to other engine components can what be taken into what full necessity. So that the B part of the question is write instruction for the replacement of a crosshead main engine fuel injection pump. So instruction for the replacement of a crosshead main engine fuel injection pump. Number one, you need to obtain the necessary technical documentation. Refer to the engine manufacturer's manual or guidelines specific to the engine model and fuel injection system to understand the pump replacement procedures and required tools and what safety precautions. Secondly, you need to gather the required equipment. After obtaining the necessary technical documentation, next you need to gather the required equipment. Ensure that all necessary tools, spare parts and equipment are available and in good working condition. This include appropriate wrenches, gauges, silent, gasket and torque of wrenches. Next you need to look at the you need to prepare the work area. Clean the surrounding areas and ensure good lighting. Next you need to isolate the fuel system, shut down the engine and follow the recommended procedure to isolate the fuel system. Next you need to remove the old fuel injection pump. Disconnect the fuel lines and electrical connection from the old point. Carefully loosen and remove the mounting bolts, taking note of their location for reinstallation. Lift out the old pump, ensuring no damage to the surrounding component. Next you need to prepare the new fuel injection pump. Install any necessary gasket or seals on the new pump according to the manufacturer's instruction. Next you need to install the new fuel injection pump. Carefully position the new pump in place, aligning it with the mounting hose. Reinstall the mounting bolts, tightening them to the recommended torque valves. Next you need to test and verify. Testing and verification is very important because this helps to perform proper installation of the new pump. Check for any fuel leaks, abnormal noise or irregularities in the system pressure, and also conduct the functional test of the engine to verify its performance and fuel delivery. So now next you need to document the replacement. So documentation is very high important when giving a report. Maintain a detailed record of the pump replacement, including the date, the personnel involved, parts used, torque valves applied, and any observation or special instruction for further references. So now note, this instruction provides the general guideline and is essential to refer to the manual. So now 8. Describe with the aid of a sketch a hydraulic top bracing for a large 2-stroke diesel engine. B. State the advantage of the hydraulic type over the frictional type top bracing. So now this is the answer. A hydraulic top bracing for a large 2-stroke diesel engine is a system that supports the top end of the engine cylinder and provides stability during operation. So here's a description with the aid of a sketch. So we have the friction material, we have the hydraulic adjustment bolt, we have the engine side, we have the ship side. So this is just a friction type top bracing. So this is just like a sketch. Are we together? So now the hydraulic top bracing consists of hydraulic cylinders connected to the engine cylinder head and the engine frame. The hydraulic cylinder is typically mounted vertically and positioned between the engine cylinder and the engine frame. So at the top end of the hydraulic cylinder there is a piston that connects to the engine cylinder. So this is the piston that connects to the engine cylinder. So there's a piston that connects to the engine cylinder head. The piston is secured to the cylinder head using bolts or other suitable fasteners. The lower end of the hydraulic cylinder is attached to the engine frame. The attachment can be achieved through a mounting bracket or other means of secure fastening. Inside the hydraulic cylinder there is a hydraulic fluid chamber that allows for the compression and expansion of hydraulic fluid. The hydraulic fluid chamber is connected to a hydraulic pump and control system which regulate the pressure and the flow of the hydraulic fluid. So when the engine is in operation, the hydraulic pump supplies pressurized hydraulic fluid to the cylinder, which extends the hydraulic piston. The extension applies a down force on the engine cylinder head, effectively bracing it against the upper forces generated during combustion. So now the B part of the question is state the advantage of the hydraulic type over the friction type top bracing. So like in this picture, this is a friction type bracing. So now the advantage of the hydraulic type over the friction type bracing is that the hydraulic type top bracing offers several advantages over the friction type. Number one, there is precise control. So the hydraulic type has precise control. The hydraulic system allows for precise control of the bracing force applied to the engine cylinder head. The hydraulic pressure can be adjusted and regulated, ensuring optimal support and stability for the engine during various operation conditions. Next, the advantages of hydraulic against friction is that automatic load compensation. The hydraulic system can automatically adjust the bracing force based on the engine load as the load on the engine changes. So there's automatic load compensation. The hydraulic pressure can be modulated or formed to provide the appropriate amount of force supply, thereby maintaining optimal engine performance and reducing the risks of damage or excessive wear. Next is reduce friction and wear. Unlike like frictional type, top bracing, there's a lot of friction, but the hydraulic there's reduce friction and wear, which relies on mechanical contact and sliding surface. But the hydraulic type minimizes friction and wear. The hydraulic force is transmitted through the fluid, resulting in smoother operation, reduced mechanical stresses on the engine component. Next is flexibility and adaptability. The hydraulic system can be easily adjusted or modified to accommodate different engine configurations and operating conditions. The hydraulic pressure can be fine-tuned to match specific requirements. So this hydraulic one can be the pressure can be fine-tuned as compared to the friction. Overall, the hydraulic top bracing provides a more efficient and effective means of supporting the engine cylinder head, thereby ensuring stable operation, reduce wear, and improve performance. So now the last question is, most medium speed diesel engines at sea do not have tie bolts. So they are asking us is that medium speed diesel engine at sea do not have tie bolts. So they want us to explain the design and manufacturing aspect of why this is possible when medium speed engines have combustion pressure equal to or even greater than the slow speed engines. So they want us to give reason why the medium speed engine boats do not have tie bolts. So now the design and manufacturing aspect that allow medium speed diesel engines to operate without the tie bolt, despite having combustion pressure equal to or greater than the slow speed engines, can be attributed to several factors. So there are a lot of factors, which up to 5 factors why medium speed engine boat do not have tie bolts. So now the first one is construction and material strength. Medium speed diesel engines are designed and constructed to withstand high combustion pressure. That's why they don't need the tie bolts. The engine components such as the cylinder block, cylinder head, the crankcase are made from high strength material such as cast iron or steel ions. So now the construction and material strength is what makes it not to use the tie bolts. Next is design consideration. The overall design of a medium speed engine takes into account the forces and stresses generated during combustion. The engine components are carefully engineered with appropriate wall thickness, reinforcement structures, and geometry to distribute and manage the internal pressure effectively. The design may include features such as ribbing, stiffening, plates, or integrated support to enhance the structural integrity. Thirdly, the bolted joint design. Medium speed engine employ advanced bolted joint design techniques. The bolts used in critical areas such as the cylinder head or crankcase are carefully selected to withstand the high pressure. So the reason why medium speed diesel engines do not use tie bolt is one, that the construction and material strength is made in such a way that it doesn't require the tie bolt. Next, the design considerations such as the engine, the forces and stress is being designed in such a way it doesn't need a tie bolt. And thirdly, the bolted joint design is specific such that it doesn't need the tie bolt. Next is the gasket design. Now these gaskets used in medium speed engine are specifically designed to withstand high pressures and temperature differentials. These gaskets act as seals between the mating surface, preventing gas leakage and maintaining the integrity of the combustion chamber. The gaskets are made from materials with good resilience and resistance to compression, and ensuring reliable and durable seal under operating condition. Next is the manufacturing processes and quality control. So now the manufacturing processes and employed in the production of a medium speed engine ensure precise machinery, accurate alignment of the components, and proper assembly. Stringent quality control measures are in place to verify the dimensional accuracy. So when making medium speed engine, there is more stringent quality control measures that are taken into place. So now this ensures that the engine can withstand the high combustion pressure without the need for the tie bolts. Now in summary, the design and manufacturing aspects of medium speed diesel engines include the use of high strength materials, optimized construction techniques, advanced bolted joint design, and robust gasket system enable them to operate reliably and safely at high combustion pressures without the need for tie bolts. These engines are carefully engineered to handle the forces generated during combustion, thereby ensuring efficient and durable operation at sea. Thank you.